where is that Google server?
Google server would be there in the headquarters of Google, no? Where else?
No.
Not really.
Cloud. Right. Bomb is dropped on the data center. Then what happens? The other data centers, they will handle.
Data center is physical. It has to be run by certain energy. Now the energy gets exhausted for whatever reason. So there's a possibility, theoretically, the data should get lost.
There are organizations who keep the data private on the cloud. That's possible with all this encryption and everything in such a way that you have your private key, nobody can open it.
So if I die, it's gone forever.
This AI has been, it's artificial intelligence. You must always remember that. Because sometimes when we talk of AI, we give too much respect to it. We think that it's overtaking us.
Don't they deserve that respect? If you have to take a debate position, let's say human being versus AI, whom do you think is more powerful? Madam, how are you?
Fine. Doing well.
So, madam, actually, I have started a series on my channel, NBT Conversations, where I want to somehow educate my audience. Let's not put it that way, that educate, but give them some awareness about the various engineering branches and science branches that at least my university offers.
Mm-hmm.
So we have covered a few, and I got a lot of requests to speak on computer science and engineering as well. And that's why you are invited here, being a professor here. So, madam, you are Professor Ningrinla Marchang.
Yes.
Did I pronounce it right?
Yeah.
Ningrinla.
Pretty well, yeah.
Pretty well, right. And so I want you to introduce yourself further to me and to my audience, like about your education.
All right. So I did my schooling in Imphal. I was born and brought up in Imphal. I did my schooling till class 10th. And then I came to NERIST. During that time, NERIST had just started.
Which year was it, madam?
It was in the year 1987.
Oh my God. Oh my God, madam. That's a revelation for me.
Yeah.
You joined NERIST in 1997.
1987.
Oh my God.
Right.
I was just a 2-year-old kid that time.
Yeah, I thought you were not born then.
I was born in 85. Anyways, go ahead.
Okay. So that's a story. So during that time, even computer science engineering field, it was very, very new. So kind of my brother's friend came with this news that they're going to start a college like NERIST for the northeastern states in Arunachal Pradesh, and computer science is one of them. And I don't know how I got this, but I was interested in computer science. But I had this desire for maths rather than biology and all that. So even in the optionals, I took maths. And I tell you, I was the only girl in the class opting for maths. And in that, we call it higher maths. Actually, we have the general maths and also the higher maths.
Higher maths. It's a new term for us.
We had it there. So all my other girl friends, they had gone for home science. And I had gone for higher maths, and my maths teacher really discouraged me, said you should go for home science, you should not stay here. But somehow I didn't like all these home science things, and then I decided to stay there. And I was, so I applied for NERIST and sat for the entrance, got in. So that was 1987. 6 years later, 1993, I passed because I joined as a class 10 student, right? And then I went to do M.Tech in IIT Delhi.
Which year was it?
1993.
Okay, you straight up went there.
Yeah, okay. Through GATE, and then after passing out from IIT Delhi, I worked there as a research engineer for 1 year under a project, and then I went down south for some personal reasons, and I stayed there for 5 years, about 5 years, worked in a private college, Satyabama Engineering College.
It's a big one as well, Satyabama.
Yeah, it was a very good college. During our days, it used to be the top ranked, but it has become a deemed university. I don't know how is it now, but
Akko sir is as an alumnus from there.
Yes. So After that, I wanted to come back this side, and so I came back in 2001 and joined as a lecturer.
2001. Okay.
Yeah, that's the story. Yeah. And then finally, I did my PhD here from NERIST, and by that time, NERIST had become the deemed university, and my PhD was the first PhD of the institute. You see,
All right.
after
You are
becoming the
you are
deemed university,
officially the first.
yeah, officially the first, because RAID was affiliated to NEHU.
Okay.
And so we could not, they could not give this kind of a PhD
Certificate,
Yeah,
right?
yeah. So
Ah.
that is the story.
So you opened the doorways for so many people. The first PhD from here. I'm a PhD from here, so I'm one of your followers. And then you say you were the only girl who chose maths over home science.
Yeah, higher maths over home science.
Higher maths over home
Yeah.
science.
Yeah.
Although your teacher discouraged, you still pursued.
Yes. Somehow I wanted maths. Yeah.
All right, I'll come to that question later. Why did you choose computer science? But my question is, how would you describe computer science to a 10-year-old?
Yes. Okay. All right. So for example, you are a 10-year-old, let's say.
Okay.
So 10-year-old means still in class 5, around class 5.
Yeah,
okay?
roughly
Class 5. So all right, these days class 5 children, they are already very familiar with the mobile. But let's not go to the mobile. Let me talk about, suppose, an ATM.
ATM.
ATM, that is a money vending machine. So when you go to an ATM, you just put in your card, and something inside the ATM reads your card, the number connects with the internet, and then says, okay, how much you want to withdraw. Suppose you 10,000 and you take out, you say 10,000, it asks you how much you want to withdraw, you say 10,000, and then it, counts the money inside the vending machine and then gives you the
That's correct.
10,000, right? So when you think of a vending machine, there's something inside that's working. You can say it's a program, or you can say it's an algorithm, you can say it's a software. Now, this vending machine solves one particular problem.
Madam, this is higher a concept for a
For
10-year-old. I mean, would they understand algorithm?
Okay. I mean, let's say something is there inside the vending machine, how you say? Okay. Which, is able to understand that you have asked for 10,000 rupees to be withdrawn, and so it does that, okay? So it does one particular task. So now, when you talk of a computer also has to be given some input, and it has something inside it, okay, that, or you say, okay, you have the hardware, you have the computer which you can touch, the PC which you can touch or whatever, but you also have something called the software. Maybe we'll come to that later on. And it solves your problem on whatever input you have given and gives you the output. All right, so I would try to say here that I'm just trying to compare with a vending machine, in the sense that a vending machine is a problem solver, but it solves a very specific problem, that is the problem of withdrawing money.
Correct.
Yeah, from the bank. Now, a computer would be something like, let's say a general problem solver. I would like to say like that. And so
a master problem solver.
Master problem solver. It doesn't solve everything, but it solves
a lot master,
of
because this vending machine is just single purpose.
Yes. So we can think it, we can take it that way. So a computer can be thought of that way. And computer science is nothing but the study of computers and how to use it to solve your problems.
Madam, your department is said computer science and engineering. Our department is said, it's being said as mechanical engineering, agriculture engineering, civil engineering. They are not said as agriculture science and engineering. In the term science is being put there.
Yes. We have B.Tech in computer science and engineering, and also M.Tech in computer science and engineering. There's a reason why we put that CSE, not just computer science.
Not just computer engineering.
Yes,
exactly.
Both. The reason being this that we want our graduates to be able to solve problems using computers, yes, and also be able to know what is inside a computer. Know the depth of it, and why is it solving the way it is being solved? Because what's inside the computer, not just like how to solve it. Now, let me take an example. For example, you have an oven,
Yeah.
or you have a washing machine, You buy the washing machine from the market, you bring it home, and you have a manual. You say, okay, you have to put the clothes in, and then you have to put water, detergent, and then run for this many minutes, and you get it. So the manual tells you, okay, how to use it. So
Correct.
we will say that in computer science, let's say, this may not be a perfect definition, but the general notion of computer science, like you deal more with the software part, you know? You deal more with the how to use it part. You deal more with what are the programs that I have to write, and what are the things that I have to give to the computer to solve my problems. So but in engineering, when you talk of computer engineering, you are actually you try to understand why is it solving, or in the sense that you're trying to look at the hardware part, the hardware part of it, and you go deep inside, and even up to that level when you at the transistor level, how it is done. As a computer engineer, you're supposed to know everything. Computer engineer will know that when a program is being fed and it's being executed, what it does, it compiles into machine language. So we have this compiler design and all that, and then after it is converted into this set of instructions, which is in machine language, nothing but in terms of zeros and ones. And now this machine language is understood by the processor. All right. A processor is, you think of the chip, the motherboard, or whatever. I know that's the layman term of saying it, but that particular chip will execute on that and give you the result in machine language. And this is again, transformed into readable, whatever, in a form that we can understand.
That's the science part of it, what you're saying, right? Like for engineers, it's more about the execution. At least that's how we are made to think, that we have to solve problem, and we have to take the components in and around, and then build a system that will be of some utility to solve that particular problem at hand.
Yes.
But not necessarily we go to the the BTS behind the scene about the science that you have said. See, because whatever you have said, as somebody who has learned computer science in school days and even in our college times, I understand what you said about the machine learning, high level, low level language, converting it. But when the software developers, as you've mentioned, in these IT sectors, they code a program to solve a particular situation, are you saying that like they just have to learn the coding part and not what happens beyond the coding?
No, they don't need to go into that detail.
It's not required, right?
Yeah, it's not required. Now, for example, a person who has done computer science and engineering, he will also be able to get into this research of, working on the memory, working on the computer architecture. There are several people who are working in these areas also. The hardware part, unless you understand the hardware part, you cannot improve on it. You cannot do those things, right? So it depends on how you understand what is engineering, but that's what we normally, think. Like, computer science and engineering means you focus not only on the software part, not only on the hardware part. You know everything about it.
Madam, when you speak about hardware, software is understood. All those algorithms, programs are understood. Hardware, like, are you meaning that the computer manufacturers are computer engineers as well? Like, are they not material science engineers? Because
oh yes, that you have many things involved there, because when you talk of the materials that are used for the the processor and all that, naturally you talk about all this kind of different kinds of materials and all that. That's different. It's like I'm talking about for the computer science that it doesn't go to that level, to that materials level and all that. But when you think of, suppose, building a, thinking of making a microprocessor, right? So a computer science engineer knows how a microprocessor works, at least to some extent. So he wants to go into research into that area to better microprocessors, like to work on improving on microprocessors and all that. He can go in I mean, that's what I mean to say. I mean, he has been given the how will I say, knowledge about what's inside the computer, also the hardware part also.
Yeah. So the hardware, the information, not the information, the science behind the hardware is known
Yeah.
to the computer science engineers, but the
Yeah.
hardware is made by other engineers.
Yes,
or-
yes. As
Oh,
that
okay.
is that hardware will be made. For example, electronics comes a lot into this. They have a specialized field called VLSI, who does all this manufacturing and all that. Yeah.
Okay. That way.
So that way, yeah.
Okay. All right. So I got some introductory understanding about what is computer science and what could be computer science. I mean, called computer engineering. Um, Madam, if I have to ask you, that okay, fine. That was about the question for the 10-year-old. Now, if you have to upgrade your definition to somebody who is already a graduate, let's say a B.Tech graduate in civil engineering, and he has joined a computer science wala IT wala job, they will have to be made understood about that as well. What could be computer science for them? I'm just shifting my question to some other floor.
Yeah.
Did you get it?
Actually, normally when they get into a job such as a software developer and all that, of course they have to learn up. They have to learn up about all that is involved, that all that is there in computer science. I mean, in computer science field, everything, and then they have to be able to use them to solve the problems that they're given. So,
Madam, when I was in class 2 or 3, I was preschool. I mean, very small kid. Yet I was, taught to code. There was a language called Logo. I'm talking about
Okay.
92, 93.
I see.
I did coding to make stars and all. It was called a very primitive language, and I still remember the logo of the Logo language. It was a turtle. So we were just taught what instructions to write, and it showed up on the screen. So what was, I mean, do you think it was a correct approach from the school side to make us learn about it when we haven't even cleared the primary schooling level?
No, I think that's really good because it helps your logical thinking. See, when you have to, write any program or create any code, it's nothing but logic. This comes, then this comes, then this comes, and if this happens, then this happens. You should be able to think logically, right? So I think that was a good step that your
Okay.
school took in.
My school, by the way, was Donyi Pola Vidya Bhavan. I studied there from 1990 to 95, and there we were, madam, as a matter of fact, we were taught French as well.
Okay.
I know a little bit of
That's
French in my primary school
I
days.
see.
And so when I went to what is that called, middle school level, we were taught this language called Basic.
Yes.
Again, it's very similar to C.
Yeah.
I mean, Fibonacci series and all. But then the point is, we were made to learn about these things, but we never use it appropriately in our future times, like because suddenly everything is in Python, everything is in Java and all. So I don't know if I'm making sense.
Now, I want to tell you one thing. You see, any programming language, for that matter, it's meant for problem solving. So if you look at the the constructs that we study in any programming language, they're almost the same. Like, for example, you talk of basic. When you study basic, I'm just talking for these
Basic, the language, right?
school students. Basic language.
Because people get confused. Basic as literal term or basic. Basic is beginners all-purpose symbolic instruction code.
Yes. So you have something like, for example, if structure. You must have used the if.
Of course.
If this, then this,
If
else
then.
this, and all that. That is there everywhere in Python also, and also in C, C++, everywhere. So once you get it in one language, it's very easy for you to understand.
Use it any
Do
other
in
language.
any other language. So I tell my students always, learn any language you love properly. So when you shift it to another, it's like using the same thing, except that you are changing the way you represent it. It's like talking English and talking French. If I say, give me this cup in English, and I can tell you in Hindi also. But I mean the same thing. So That's what it means.
All right. Um, what is, madam, one concept of computer science and engineering that amazes you still, starting from your journey way back in 1987 to 2025? That one thing that you think, oh my God, what is it?
Yeah, actually, the internet, the internet is considered like it has really transformed everything. So this technology has transformed everything. Say the year of invention, people give it as 1983, but it
Which year,
was
madam?
1983. But actually, it started as U.S. defense project. They had these many computers in the defense organization, and they had connected them, and they'd call it the ARPANET. They wanted to connect, and then they want to share information with each other and all, but that was just local in that area. But later on, it caused other computers started connecting with each other and all that. And in 1983, the TCP/IP protocol came. Protocol is nothing but a way of speaking. When I speak in this, you will understand. Suppose if I give you something in this format, you understand that format, and you're able to understand. And when you want to send something to me, you put in that format and
Like
send.
code of conduct kinds.
Yeah, kind of
SOP kinds.
SOP kind of a thing.
Okay.
So it's like this: when many different independent entities are going to communicate with each other, we should have a protocol type of thing. So this protocol came about, and everybody accepted it, and then it became like everybody could talk with everybody else, that kind of a thing. So, and of course, with the internet came the www, World Wide Web, and all that. And it's just like, why do we say internet is a technology which is accepted as the most transformative? Many people accept it. It's not that I say it, that's why it is. Why? Because of the internet, it's like the whole world's resources become mine.
Right? Correct. I have access to everybody.
You have access to everybody. You may have to pay a little bit. Some are free, some are not free. But you have the world's resources. You can download anything from anywhere. You can, that kind of a thing. So it's like it has opened up.
Madam, I know nothing about internet. The science behind internet.
You're using it.
I use it. I know not. I don't know about it. I use my mobile phones, but I don't know the technology that's running inside the mobile phone. Of course. So that way, what is www? What does it even mean?
www is what is we have the world of you say www, the World Wide Web.
Correct.
It's like a digital place where you. Now let me put it more simply. It's like, now for example, in Arunachal, this is a place. What are the resources that you get? You can come here. You can there are houses here, or railway stations, airport. You can make use of them and all that. These are the things that are available there. So World Wide Web is a digital area, digital space, you would say, or where people can put in their documents or their websites and everything.
Okay.
And
it's like a marketplace. No.
Yeah.
Like
It's-
where you put your stuff.
Yeah, exactly.
Oh.
It's like a basket where everybody puts their stuff. And you've opened. You said, okay, anybody can use it. Anybody can browse, right?
So when I say www.ningrinlamarchang.com, it means that basket ka particular pocket you have to go.
Yes.
It
you have
means
to
that,
go
right?
in that. But it's not as simple as that, because I have to register my domain. Of course, that Yeah.
No, I don't know, madam.
Yeah. Suppose I create a domain for myself, and I create
What is
like
domain?
that. Now in this there is a kind of you would say the governing body. Not exactly. You won't say a governing body. See, suppose you say, okay, www.nbt.com. You must have registered your.
No. I don't know. I wouldn't for quite some time. It's only on YouTube. That's it.
Yeah. So the domain name service system, that's kind of a service where you say that, okay, you buy, actually you pay some little amount of money, maybe 5,000 or whatever.
I buy from whom?
Yeah, there's a service provider, right? So what you do is you buy the domain. Then what happens is they put in their DNS server, a domain name service.
Okay.
Sorry. So this domain name service, you put it there. It is the the registry. Okay. So when anybody says www.nbt.com, they will be
Directed.
directed. It's
So
like a
www is the superset,
kind of a thing.
and
Yeah.
all the domains are subsets of it.
Yeah. You
So-
can say in that.
So
you
does
can
it
tell
ever get
that.
exhausted? Like, is there any capacity?
No, unlimited. As
uh,
long as you can always provide your servers and all that. It's unlimited.
One more thing: who owns the www? Who is the owner of it?
You have this. The details. I have not gone into that, but there is like you have this domain name service which they provide, and then this is where you register. Nobody really owns the www in that sense that okay. This is, suppose you have uploaded something in your website. Okay, this is mine. Nobody says that.
No,
It's
that's
yours.
no. By who owns it? I mean, like someone created www, and because we are
Uh-huh.
using the service,
Uh-huh.
does that creator get any benefit that we are
Um,
using his creation or her creation?
No, not that way. Internet is it's a really beautiful thing. It's a funny thing. There's no
knows-
honor.
No owns it.
No,
No one owns
nobody
it, right?
owns
Okay.
So it's like this that I want to make use of the internet. So suppose you are not that your office is not connected to the internet. Suppose, and you say, okay, I want to connect to the internet because I want to connect with everybody else in the world. I want to download anything from anywhere. So what do? You buy a wire from the market, the specified wire, and then you tell the ET cell, okay, I'm going to connect it. ET cell is our department who takes care of the internet, and so you just connect it. They allow you, and then you connect it, and you're connected.
So it's like
So your wire is owned by you only, and at the same time you're on the internet. So it's a beautiful thing. Internet. There's no honor really.
basically internet is like the air in atmosphere. It's the electricity that's possible. That if you can tap it, it's yours.
Yeah, it's a river that's there.
It's
and
a river.
You can tap in. You can
Ah.
if you want to make use of that river. You.
I
go
just
with
need to buy a cup.
a cover. You go and get it. Yeah,
I'll get something of the river, and when it okay.
because nobody says you cannot connect, isn't it? Whenever you need to do anything, normally we take approval and this and that. But when you want to connect to the internet, you don't need to take approval from anybody because nobody owns it, actually.
So the one who provides infrastructure for internet connection, let's say all these service providers like Jio, Airtel, and all, they make money through us, right? We pay them only for the data. So
Yeah.
they are creating a model or a system through which they tap the internet, and that limited quota of internet is given to us, daily quota. How does that work now?
We will not say they tapped the internet. They have given you the resource.
wire.
The wire. Let's say the wire. Or
Ah.
if you're doing talking about the of Wi-Fi or whatever, through the mobile data, you using the spectrum, which they have bought from the government. You see that?
They bought from the government.
Yeah.
Now someone is making money, not for internet. It's the government, right?
Someone is making money
It's like,
for the resource that they have bought from the government.
Let me put
Let's
it
say
in
like
context.
that.
Let's discuss this. Like the roads and all. I mean,
Yeah.
we use roads not for free. We pay taxes
Yeah.
to the government, right? Somebody owns the roads,
Mhm.
road infrastructure. Now, the same question is what I was asking for the internet. There's a service through internet that we avail. Internet is not nature. Like air is free for us. The river water is free for us. So because it is being provided by nature, not humanly created. But internet is created by some human being.
Yeah.
So I
Yeah.
hope.
Okay,
Did
I
I
think
make-
let's put this into perspective. Internet is not something. See, it's not a resource, a tangible resource that you can go and touch. You can go and think. It's like this internet. It's just a technology. It's a connection of all computing systems all over the world. You say, okay, that's the internet. But now, how to use the internet? You need a cable, for example. To connect to the internet, or you need a mobile data, so that mobile data subscription, so that you can use the spectrum. And this, suppose the wire or the
Antenna and all.
antenna and the spectrum that you use, the radio spectrum, that band that you use, that is given by the service providers. They are not owners of the internet. They are not owners of the internet. Is just how will I say? It's not something you can touch or anything
It
like
sounds
that.
like the mystical concept of consciousness is already
Exactly,
there.
exactly. It's like you are, if you connect, if you are able to, it's a connection of all computers. That's the meaning of it. But how you connect and who you connect, how you connect and all that. That's up to you. Use a wire or you use wireless and all that. But those people who sell you this spectrum band, okay,
By
so
spectrum,
that-
you mean the
yeah.
pipeline through with the.
Yeah.
It's just like a
We're
pipeline.
talking about this. You're talking about these internet service providers.
That's
like,
what. The 3G, 4G, 5G, they are all like.
Yeah,
what I
yeah.
understand is like the bandwidth, the amount of
yeah.
data that you can pass
Correct,
through a certain bandwidth.
See, so but that is not anything to do with internet, first of all, because using that we can make calls. Using that you can do so many other things.
Correct,
Yes,
correct,
like
correct.
communication and so on. But that is the how the conduit through which you join the internet community. Let's think of internet as a community only. That would be better. It's nothing physical, nothing that you go and touch and all things like that.
Somebody long time back when internet just started in our times, like 91, 92. I don't know if it's right, but someone said that internet stood for international network. I don't know if he made sense or was it factual. Do you have any idea? Madam?
International, you cannot really say that it's an internetworking of
Okay.
systems. That's it.
Okay.
You can say like that. International would be too
Maybe somebody said
limited
that
a term.
back. Yeah, that's correct.
I think so.
Yeah, international
You can talk over it also. You can say that.
But international has a certain other connotation, but it is more about interconnecting.
Yeah, interconnect. It's just interconnecting. You by interconnecting it, you are able to do a lot of things. It's like just like a community. Yeah, it's like a community.
Like it's like you are there, I'm here,
Yeah.
I know something, you know something, and
Yeah.
we are just exchanging
Yeah,
ideas
yeah.
for free.
Mm-hmm.
Now, if someone wants to take the idea that we're talking about, might need to capture us through camera. Now, camera is a tool through which this networking that is happening between us.
Yes, exactly.
That's a
Yeah.
tool, and someone
Yeah.
has to buy that tool, and
Yeah.
that's what you pay. Or otherwise, our communication is for free.
Yeah. And it's, I want to connect with you, I connect with you. I don't need to ask anybody any
Yeah,
permission.
that's correct.
I just need the tool which I buy from there. So that's what you're doing with the internet service provider. You're just buying some tool to connect with others through the internet.
Okay, so www is understood. It's like the basket that you said. Internet is almost understood. It's still quite abstract to me. There's something called IP address. मुझे नहीं पता कुछ भी. What is IP address?
Yeah, IP address. I also taught this subject long back with the IP address. Just let me just plainly put, it's just like an identity. So suppose I have an IP address and you have an IP address. When I send something to you, I should put my address also, so you know who's sending you. That's what it means.
Like by address you mean this mobile phone will have a certain IP address? No.
Yeah, actually IP address that way in that
Okay, 1 second. Let me
yeah.
put question in the perspective. Would IP address mean Ningrinla Marchang and Navamtai, or would it mean Navamtai of Mechanical Engineering Department and Ningrinla Marchang Computer Science Department?
Yes. It will be unique in the sense, right? It will be unique in the.
So Navamtai is unique. My address is not unique, no. I am unique.
We call it IP address, but let's talk it as an identity.
That's what identity. My name.
ID, yeah. Your name and it should be unique. If there's any other name Bamte in the world, it should not conflict with that name.
Okay.
So it's a unique identity. Yeah. Let's just think of it as a.
So
unique
there are
identity.
infinite number of IP addresses.
Oh no, not infinite, of course, because we have a limited number of bits that will represent the IP address. But it's enough to cover the billions of devices, right, in the world. That's it.
No, as you said, if I'm sending something to you, there has to be some address to which I'm sending.
Yeah.
So there are zillions and infinite times of people sending anything.
By that I mean to say that, for example, the mobile number, you have 10 digits, right? You have 10 digits. So your mobile number is, suppose mine was some number, yours is some number. Now, there are so many people in the world, there's so many mobile phones in the world. How many possible mobile phones are there in the world, for example?
We have 7.5 billion.
Right. So what are the possibilities? You see that first digit can be 0 up to 9, right?
Correct.
Second
Correct,
digit can be
correct,
0 up to
correct,
9.
correct, correct.
Third digit can be 0 up to
Correct,
9.
correct.
So you have 10 possibilities for each of the digits. So 10 into 10 into 10 into 10, 10 to the power 10. That's a very huge.
Yeah.
That's the reason
Okay,
why
okay.
you say, your IP address,
Okay.
that way it has a limited number of bits, but it's able to take care of the billions of devices that we have.
Fine. I'll continue with the motion or with the momentum we are talking. Internet is one thing, which is, as I've understood, when during the 80s and the 90s, they were all hardwired. Right.
In the sense that hardwired.
Wi-Fi.
Okay,
Wi-Fi
you're
is
talking
a
about wireless.
wireless fidelity is a 2000 concept.
Okay.
I don't know if I'm making it right, but in 90s we never heard about. In our school days, we never knew about Wi-Fi. It's only in our college times we got to know about this Wi-Fi.
The technology would have been there, but it's because of this problem of how will I say, if you send information into a wire, you won't have too much of noise coming in there. But when you send by this Wi-Fi or whatever by air, you'll have to deal with more. So those could be the reason, but of course, yeah, it came in later. It came in later.
Okay, so 90s internet, that wired internet, to Wi-Fi in 2000s. Now in 2010s we have cloud computing.
I'm not very sure about the Wi-Fi's in 2000.
Okay.
So I will not really.
So anyways, we have a very clear disclaimer here. We don't claim to be, like whatever we say is like, क्या बोलते हैं, final type का तो कुछ नहीं. We are just discussing.
Yeah, even internet. Some people will say, okay, internet started in 1970s, 1969, 70. This, I told you about the U.S. Defense Organization. They connected the computers. They had the ARPANET. That's from 1970, around 1969, 70. But people, they accept 1983 because that's when all the computers, they could connect with each other. I mean, using that protocol.
Right.
So some people may say this, some people may say that. That's okay, fine.
Okay, so now I was coming to this point of cloud computing.
Oh, yeah.
This is a 2010s technology. I think
it's a very recent one. It's
Yeah.
a recent one. I won't like to give any date, but anyway, thing.
let us
But
go to
it's
the
a very
fact of it.
recent one. Yeah.
Now what is that game again?
Yeah, actually, it's very interesting. Actually, but when the computers started initially, when the computers were created or developed initially,
Talking about 1940s.
all right, let's say 1914, not 1940s, 1960s or 70s.
First
You
generation,
say,
second generation,
yeah,
third
that
generation,
kind
fourth
of
generation
a thing.
computers.
Yeah.
We were sort of
So
like
let's
that.
talk about the first generation digital computers and all. They were these big machines which only universities could afford or some big organizations could afford. And so people used to come with their jobs and come and, say, okay, please solve this for me and give me, this is my input, and they would solve it for me, get the result printed out or something like that. I'll come after 2-3 days and come back and collect my thing. So that was the thing. So people used to use a common kind of a source, right? A resource, which was there in the university and all that. Then later on, it started like, okay, everybody said, okay, I want to have my own PC. I want to have in my room. I want to watch video. I want to watch music,
That's why computer has become
So then
personal computer.
Yeah,
He has
personal.
come.
So it became personal computer. Everybody had a personal computer. They could afford it. See now, it made it affordable. So everybody got very familiar with personal computers. Because initially only like researchers, scientists, those who were really doing work which could require computer to solve it, they used to go for this big mainframes and all that. So now when it became personal computer, everybody started using, grandmothers, grandchildren, everybody started using it. So everybody got so familiar with the personal computer. Fine. That came, and then later on, this cloud computing which came in, it's like saying, okay, now, see, if you have a personal computer, suppose your disk crashes, what happens?
So every data is
You lose
lost.
everything, right? And so you try to put an external drive and you try to copy every time, but you feel lazy. Okay, I'll copy once in a month. But then suppose it crashes, you lose 1 month's data anyway. So this was the situation. Just putting it very plainly, then people started saying, okay, now suppose I have my PC, but then I don't want my data to be lost at any point of time. So what I do, I want to upload it, all right, somewhere, That's a cloud. Okay, I'll explain to you what is the cloud. And I want to upload it to some cloud server so that even if my hard disk crashes and if I buy a new computer, I can always download it and I have all my data. Okay, that's the simplest application, you say. So now it became a big hit, right? Why? Because this is one application, a simple application I'm giving you. So now because of this cloud computing, everybody could use it. For example, you have Google search. You're doing Google search, but you have the front end. Front end means you have the app that you download, you have in the computer, and you use that. But when you do Google search, what is it doing? You're giving your terms, like you're giving your the prompts or the query terms or whatever. Suppose NBT channel, if I give
Query terms is a better word. Prompt will come for the later
Yeah,
part. When
yeah,
it come into the picture. The prompt has become a new buzzword.
yeah,
Anyway,
it's a
so,
buzzword. Okay, those
questions.
who are not familiar with ChatGPT and they'll find it difficult. So there's a queries,
correct.
whatever. And so it takes that, and then what is it doing actually? It's not working here in your computer, right? It's connecting with the cloud. So we don't know where this
1 second. It's
search
connecting
engine.
with the cloud.
Yes, I mean to say that the search engine, Google search engine, is not sitting here.
That's correct.
Right? You are just connecting with this computer, with whatever you have here. No, whatever your what is that?
My
Chrome or
Chrome
you
or-
download it and then you use it. It's a program, and when you give the terms there, query terms there, it takes it and it's connecting with the server out there, and then searching and then bringing it back to you. So where is that server? Where is that Google server?
Google server would be there in the headquarters of Google. No, where else?
no.
Not really.
Cloud.
Cloud.
Right. In the cloud, in the sense, I'll tell you what is the cloud that way. Cloud is, so we say that it's in the cloud, it connects to the cloud. So now, when we talk about the cloud server, it doesn't mean that it is one physical server there. It could be 100 servers serving as a cloud server. Okay. So, serving as a cloud server. So this is again, a term which say, okay, I've uploaded to the cloud, but I don't worry about it, right? I don't know where it is stored physically, actually, right? So
But I always thought cloud to be a physical server somewhere.
it is a physical server
It is, right.
somewhere,
Okay.
but the user, you as a user, doesn't know where it is stored,
Yeah.
how it is stored, and all that.
Correct.
And so you have this big data centers all over the world. You have this big which they have this servers high, like big servers, and they keep them running all the time. And then that is another another area altogether. But when you talk of a cloud, you say I have uploaded to the cloud. Suppose Amazon gives you these cloud services, right? You want to. There's so many cloud services, not a very big topic. But just simply put, when I say, okay, I have uploaded my hard disk content to the cloud, we don't know where it is, but it could be using so many servers around the world.
Let's say, okay, I put my data in Google Drive. Google Drive is a cloud service.
Yes.
So with that example, what I was saying, it could go to any other of the servers of Google that we don't know.
Yeah.
That the Google headquarters will, take care where to put.
Yes.
But
yes.
eventually it will be in some hardware.
Yes.
Come
Eventually, yeah. That's where the data centers are, right? Where they have the big servers where they're actually storing it. Actually.
So it will have a limited capacity. It cannot be infinite.
Cannot be infinite, but they're expanding like anything. I just, very recently I had a talk with one person who was actually building a data center in Chennai. Not in Chennai, sorry, it's in Tamil Nadu, some other place. They're even thinking of making data centers in the sea. Technology is such that people are willing to invest in all that. There's no limit, it's like you can upload as much as you want and all that, right? So you can always expand the capacity. So there's no limit. Right?
By data center, you mean the servers only, right?
Yeah, servers.
There's no difference, right?
Yeah.
Okay.
The servers which store your data and all that. The data center is nothing but a center where you collect, where you're keeping a lot of the servers, where we store your data. That's why it's called a data center. So a data center may serve many people, many organizations, like Google may be one, or AWS. So data center is owned by somebody else again.
I get it now.
Yeah.
Data center infrastructure is owned by somebody else. And then I might use, as the owner of Google or Amazon, I need a part of your,
exactly.
that space of your data center for myself. And so he'll be providing the service.
Yes.
That's how it works, right?
That's how it works. So, but we don't know this big tech giants. They may have their own data centers. That I am not very sure. But the technology is like that.
All right. Interesting. It's see, I've never actually thought. I've never had to think about computer science to this layered understanding, because for us, although I'm an engineer myself, but the thing is, we only care about the utility part of it, not the, as I've said, BTS, the behind the scene, whatever happens there.
And I will add another thing here, okay, just for you to see. We don't bother. We take it so, we think that it's so normal. Okay, I have uploaded it, and I don't worry about it. I know it's going to be safe.
But by the way, is safety 100% guaranteed?
Yeah, 100% guaranteed.
Unless I delete it myself, right?
Right,
Okay,
exactly.
okay.
How do they do that? Suppose, so 100% guarantee is actually a theoretical guarantee, but they have put in so much of replication, mirroring, so that, or replication, let's say redundancy, so that it's practically possible to give you 100% guarantee. Now, for example, just very simply put, let's say, suppose the what we are uploaded on Google Drive, okay? Suppose Google Drive is from Google, so they will be storing in some data center, but they don't store. I mean, this is put very simply. There are different techniques of doing this, but they don't store in one particular place, only one particular place.
They duplicate in.
Because, yes, they duplicate in many ways. And duplication also, it's not just like duplication. They have different techniques where, okay, if you say, okay, you have, if you lose this, you can again create it from something else and all that. So just think of it as duplication or redundancies. And so if this fails, suppose a bomb is dropped on the data center then what happens? The other data centers, they will handle.
Because
data
center is physical. It has
Exactly.
has to be run by certain energy.
Yes.
Now the energy gets exhausted. Let's say electrical energy. Electricity for whatever reason. So there's a possibility. Theoretically, the data should get lost.
Yes.
But then you have, as you have mentioned, that you've used the term redundancy, which in layman term we could say duplication. Right. Same things being repeated. So you are somehow ensuring that it is stored somewhere in some other ways, in some other technique. That there's a way to retrieve it through that certain other technique as well.
Exactly. That's what's really happening in everything. There's this redundancy. We call it parallelism.
Parallelism. Okay. Makes sense.
Yeah, that kind of a thing. So when you upload to the cloud, you don't call Amazon, or I want to put in that data center. You don't say like that. You just give it to them, and that's their responsibility. And theoretically, it's like 100%. Practically also, you can say even practically now, you'll never lose your data unless the whole earth is eliminated, isn't it?
I do have a practical what is that called? Proof of what you have just said. Just a few days back, one of the data from this camera got lost through my what is that called? SD card.
Okay.
It got lost and we couldn't find it, and we were like, it was a very important guest, and I couldn't afford to get him back again, so I lost a very good conversation. But then somebody, one of our students, my own mechanical engineering student, his name is Rishi Raj Tamoli, right? This guy somehow out of nowhere brought that back, and I was like, "ये magic का से हुआ?" Now what you are saying, मेरे को समझ में आ रहा है. Even if it gets lost, of course it was not uploaded in the cloud. It got lost from the SD card. Somehow through the SD card it went somewhere in some of the data centers somewhere.
Somewhere it was uploaded.
Somewhere, and by default it got uploaded automatically. It got uploaded. I don't know whatever way, but through that whatever route it was taken, it took him the whole day, but he retrieved that particular video back.
That's what we are doing for everything, even for mobile. You suppose if somebody steals your mobile,
Mm.
you can download everything, all the phone numbers and everything. You have uploaded in Gmail. You have done that. You must have done that.
Yeah.
Yeah, I had broken my phone, so I
Ah.
had to get another phone, and so
You retrieve it.
I retrieved all this thing from Gmail because I had saved in Gmail. So that's nothing but cloud. I had always saved there, and then always saved, and then so I got everything.
But-
So that's how cloud computing has made
Okay.
it really, really.
Okay.
I mean, how would I say? I don't know. Made life simpler.
Madam, who created cloud? It's a group of scientists or one person? Like,
No, it must have come up as an idea. Normally, I'm not very sure. I didn't read about the history, but I mean, of course, I did not teach about cloud computing also because there are even courses on cloud computing and all. You can go into a lot of details and all that. I'm not very sure about that. How it happened. I have not looked into that.
would that mean that none of our data is actually private in total, in absolute term? Somebody is always there who can actually access my data. At least somebody, somebody in the data center knows what I'm up to.
No, there are privacy terms that they respect. Like, for example,
Respect is and again, it's not a physical
no,
term.
if you're allowing, say, suppose I move around and then Google sends me an email and says, okay, you were here, your timeline, you were here in Delhi at that time, and then there's this thing and all that. It's because I've allowed it to do it, right? But if I can set my privacy settings in such a way that it does not track me. But anyway, it can track a lot of things. But what I'm trying to say is there are organizations who keep the data private on the cloud. Okay, that's possible with all this encryption and everything. That's the technology behind. Encryption is in such a way that you have your private key, nobody can open it. You have locked it using your private key, nobody can open it.
So if I die, it's gone forever. It's gone with the grave.
Yeah.
Nobody can open it.
Yeah.
So WhatsApp
Unless
is,
they're able to find out your password.
WhatsApp is called to
Yeah,
be end-to-end
end-to-end
encrypted.
encryption.
But
Encrypted.
I had the idea that there's somebody in the server who can check my messages.
And the server.
I mean, wherever through which WhatsApp.
No.
Nobody.
No.
Just-
In the sense that, see, encryption is like, this is another section of computer science. You use encryption using cryptography and all that. It's like this.
No, I didn't encrypt it, right? Who does it for me then? As you said, you need to give permission to Google.
They will not, when you create your WhatsApp, you use your phone number and create, no?
Yeah.
They'll use some of your part of your identity, like the phone number and all. They'll create the
Encryption.
the encryption key for you automatically.
Which I'm not aware of. They do it
Yeah,
for myself.
yeah, they do.
They do it for me.
Yeah, they will not, but they will not be able to see that, and then you are going to what is that you're going to use this for all this kind of thing. There are different kinds of cryptographic techniques also, and most of the internet, the security that we have in the internet, we use this there's this RSA cryptography algorithm and all that, and that's there were other things also, but you have
I think I think I have a myth that I've always believed in. Maybe I'll put it here and please correct me if you can. I thought WhatsApp was bought by Facebook for $19 billion. I actually thought that. See, I didn't understand the business model of WhatsApp for quite some. I really didn't understand. WhatsApp is such a high utility tool and app, but it was for free for us. Now, if it's free for us, whoever created WhatsApp and whoever handling the the headquarter of WhatsApp, what are they making money from? How will they sustain themselves? So when it got sold to Mark Zuckerberg for $19 billion, there it clicked to me that perhaps this is what their plan was. I'm sorry, I don't know anything. I'm just blabbering, perhaps speaking gibberish. But I thought that $19 billion that the WhatsApp was sold for. So whatever investment they had done all those through these years, with these guys not getting any money from the public who's actually using the users of WhatsApp, it finally got realized. They got their money. Now, why would Facebook buy WhatsApp, I thought that whatever we text to anybody, that texted data is being seen by somebody from Facebook. And so if tomorrow, let's say at 3 a.m. at in the morning or at night, I text somebody, I'll be gifting you a blue jacket tomorrow. You just tell me your specifications, and if that is being seen by people from Facebook, they will customize that blue jacket with the laces and they'll put it on my face for ad, and maybe that's how the business model was. That's what I thought, and I think.
But it's an end-to-end encrypted, and
Okay.
this has been a big issue because many activists and all who have been targeted, and so on. I mean, those who want to communicate, secretly, they use WhatsApp because phones can be tapped. We all know the story and all that, but end-to-end encrypted. But I'll tell you, even if they don't get money out of using your data or anything like that, but they've got the consumer base, right? I don't know. That's my thing. They how many people use WhatsApp in the world?
Oh, everybody.
Yeah, everybody.
Everybody mobile with the mobile phone.
But once this end-to-end encryption goes, maybe some people will come out. We don't know.
All right. So, matlab, that's what, madam. I was almost making my own theory, and I kind of not promoted, but I expressed this theory to people as well, who's ever had sought my opinion. How was WhatsApp making money, and why should Mark Zuckerberg buy WhatsApp? Because if it's as you said, consumer based, they got it. Fine, madam. We are moving linearly. I had the intent to ask you some other questions, but I'll carry on with the momentum in the same direction.
Okay.
We started with the internet. We started with the hardware, software, very basic of computer science, and then we moved to the internet part of it. You brought the internet because when I asked you what images you steal, you said the internet images you steal. Then with internet came cloud. Now we have AI. Let's go there now. Now, what is this game of AI, man? This is
AI has been it's artificial intelligence.
Yes,
and it
that's
is
it.
really artificial. You must always remember that because sometimes when we talk of AI, we give too much respect to it in the sense that we think that it's overtaking us or whatever.
don't they deserve that respect?
All right, let's talk about artificial. It's artificial because it is imitating human beings to, to how will I say, to do tasks that human beings are doing. That is what AI is about.
Even mechanical engineers, the kind of mechanical systems we make, they somehow imitate human beings only.
Now AI has come big, very very big now, but the concept, how will I say, to make a human to imitate the brain, how it learns and all that, it had started long back. But the problem was that it was slow, right? I mean, whatever. Now let's talk about the basic thing: neural networks in AI. Other things also used, but this is the basic one, right? This is the neural networks. Is this is the main engine, let's say. All right. So this was there long back, but we didn't have the speed to run these things. Right
Okay,
now,
the infrastructure was missing.
yes,
the technology was there.
The technology was there.
But
There was
infrastructure was missing.
Some other very great mathematicians that already come up with that to mimic the human brain, how it learns and all that. So I still remember when I was in 2018, I think I went for a workshop in ISI Kolkata. There was a guy from IBM Research, and he was talking about natural language processing, like the normal thing that we're doing with ChatGPT. It's not going to be possible because ChatGPT understands the concept, the context. You're talking about, suppose, a bank, you're talking about money transactions, and you say, okay, I went to the bank, for example. They understand that bank means the bank, the money bank, the bank where you withdraw money, not the river bank, right? So ChatGPT, they've taken this, they have been able to understand your context and everything. But this guy, 2018, only 2018, that is how much? 7 years back. And he was telling that, okay, it's going to be a big, it still is difficult, getting the context. And he was giving an example. Somebody says, I want H2O, right?
Okay.
Please give me H2O.
Okay.
and somebody brings suppose a glass of water. I want H2O to the machine. Okay, suppose the machine is able to provide, okay, give the order, H2O, and it gives me a glass of water, I drink it. Another person says, I want H2O2. So what is, that's poison. Hydrogen peroxide, it
Hydrogen
becomes
peroxide,
H2O. Yeah. So the machine, suppose the artificial intelligence system or whatever, it will understand it as hydrogen peroxide and give you hydrogen peroxide and you'll die, because it doesn't understand the context. When I'm saying H2O2 means I mean water 2, TWO2, right?
Yeah.
But it may understand. That's what he was trying to take an example and explain. So even during that time, this concept was very, how will I say, it was still in research area. So now, and during that time also, there was this guy from NVIDIA who came up with this GPUs. Talking about the GPU, and he was talking about the evolution of GPUs. Now, because of this GPUs, the speed has been so mighty, because of which we're able to have, artificial intelligence that way.
Okay.
It's able, the speed at which you can learn is so fast that now it's able to serve to serve humanity. And now another thing is coming, that's quantum processors. Quantum computers.
Madam, we'll go there in it.
That's really going to accelerate everything.
A little later. We'll stick by AI for some time.
Yeah.
Okay.
All
So in one of my conversations with someone from mathematics, Dr. Ningrinla Chatterjee,
Okay.
we spoke about AI for some time, and I almost said that very affirmatively, that AI will take over human beings in a way that I made the statement that human beings are also algorithm only, the way I see it. We only process our data, and our operating system is made by what we have become during our formative years, where we didn't have the capacity to reject things. Let's say our 5 to 6 years from our born time, whatever data we consumed, and what my parents, my society, whatever, because we couldn't reject things. It was given to us, that has taken a shape, and it has become my, for that matter, let's say a nature, a character. And then when we go beyond 7, 8 years, 10, 12 years, we kind of decide what is good, what is bad, and what is good for me, what is bad for me, and then we reject things as well. But yet still, my operating system has been developed. Meanwhile, all through this biases that might come through the environmental impact, things beyond me, I'm again just an algorithm. Now, what AI is also an algorithm. He gave me an example. Sir Nilabja had given me an example. If you think that human beings and AI can be drawn parallel at the same pedestal, then if you are a diabetic patient, then you shouldn't be eating a rasgulla anymore, gulab jamun anymore. AI will not eat that gulab jamun if AI is diabetic patient, but you will, because that desire of taking thing is with human being, and we ended there.
Yeah.
But I have further to say that you having the desire to have rasgulla is a program that has been repeated for a longer period of time. That has perhaps become your, in Hindi it's called sanskar. It has become your habit, a part of you. If AI is being given that kind of a feed as well, I think it will also want to eat rasgulla, even if it knows that it's diabetic.
I wouldn't really take it that way, because when you talk about the rasgulla, okay, you may have the desire to eat it, but there's one important concept also, the will. We have the will, right?
Yeah.
Somebody has diabetic and he will not eat rasgulla because he knows that it's not good. He uses his will to say no to it, because even if it's very, very tempting. Another one will eat because his willpower is not so great, or he is very, very fond of rasgulla. So,
but AI will reject it right up because it's programmed. It doesn't need the willpower.
That way it's programmed. Suppose an AI has been programmed based on your life.
That's
then
what I'm
probably
saying.
It will have.
That is what I was saying.
Okay.
Based on my life, all my data is being fed to that particular genie called AI. then he knows me inside out. He knows me more than me, myself. So he might actually want to have rasgulla even with being diabetic, because that's how I have been all through my life.
But then if you had not rejected Rasgulla those days, then it also will not reject, because it's just imitating you actually, isn't it? Because that's what AI is. See, AI is of course it coming in a very big way. It solves a lot of problems. It is solving a lot of problems in the health sector, every sector, agriculture, anywhere. It's able to solve problems effectively and efficiently, and very very interested in that, because
Madam, if you have to take a debate position for AI, or not for AI, let's say human being versus AI, whom do you think is more powerful?
Now I will say this, that AI should be under control of human beings. Okay.
That is your wishful thinking. I'm asking you, as a state of being, state of art, human beings state of art, and AI state of art, which is more powerful?
When you come to the idea of super intelligence, which people are talking about, just I think yesterday or day before, Sam Altman, and the founder of
I missed that.
OpenAI.
What happened?
Yeah, he's telling that super intelligence will get in 10 years time. Just in 5 to 10 years time.
Oh, with the quantum computing in the picture, that infrastructure is getting developed, right?
Correct. That is also there, and he says, now super intelligence is something like more intelligent than us.
So,
Okay.
Madam, do you consider AI at this point of time? Do you consider AI to be more intelligent than us?
No, right now, no.
Really?
Yeah.
Okay. Let me.
I mean, when you say more intelligent than us, means it should be able to do all the tasks that I do. Okay.
At least a mental task.
Mental tasks. It's talking only about mental tasks. See, when we talk about intelligence, we're talking only about the intellectual capability. Okay. It's not can do nothing about emotional.
But emotions are just chemical reactions.
No.
AIs don't have chemical reactions, right?
See, it may solve all the problems, but it doesn't solve all the problems that humanity faces. That's the reason why, it doesn't solve everything. Okay? But accepted that it makes life simpler, it makes us more comfortable, it makes us lazier, right? It makes us travel faster. All these things are there. It solves a lot of challenges faced by humanity, of course.
I'll put something on the table now for you to explore. We human beings can only operate or manipulate this amount of data that's being fed here throughout my lifetime.
Yeah.
Whatever that includes, whatever I learned today by talking with you, and whatever I learned yesterday by talking to somebody else.
Yes.
That is this amount of data. Now, AI has the data of all over the world with that capacity. That means he has more things to process, and so he has more examples where things might work better, because I think AIs are of course they are biased technically, but they are non-biased, as you've put it that way, personally or emotionally. So they will make a more neutral decision.
See, AI by itself can't do anything actually. When you say bias, it's because people who have created them have made them biased.
Bias, correct.
Now, for example, people talk about Grok. I have never used Grok. So there's some bias over there, right?
I've never used Grok.
I also have never used. So if you look up about some items, some things, it doesn't tell anything, or that kind of a thing. Why? Because the people who have created them biased. Because even when you talk of ChatGPT or Gemini or anything like that, the models that are involved there.
Madam, you use both?
Architecture, pardon?
You use both?
I use only Gemini right now because
you don't use ChatGPT?
ChatGPT, I use a little bit. My son uses it for his studies, but we have bought Gemini, so we're just using Gemini. For me, it serves a purpose. So, as you said, you see, this is where super intelligence is coming in, right? You have the data of all of the whole
everything
world, of everything.
Infinite data, actually.
And
we have limited data.
Yes.
They have infinite data.
Yes. So it's able to see, how do you do research, for example, just example, right? When you did your PhD, You said, okay, this is the area that I want to work in, and you find out all those people who have worked in that area.
Literature
And
review.
you literature review, read up, you spend time, spend 1 hour for one paper, or maybe even 2 hours for one paper.
One day initially, initial days, one day for
Goes
one
on.
paper.
Yeah, exactly. And we go on, and then we say, okay, what's the research gap? What is missing there, and how do I solve it? What are the different ways people have solved it? And so I should not repeat, I should not reinvent the wheel, so I should do something else, that kind of a thing, something more efficient. You do all that. So now AI, I mean ChatGPT or whatever, there are tools, AI tools for, particularly for research, like Undermine, which came out recently, and they're able to give you in minutes.
Correct.
Whatever you're doing, whatever you
Yeah,
have been doing in literature survey, in minutes. I've tried actually, and so you get all that, and then they give you they sorted in order of relevance. 100% relevant is this according to how you have searched, and it gives you the comparison, the tables, and everything. You see, and so there's so many things that can be done. And so when you talk about super intelligence, at time, that's what they say will come when it will be more intelligent than human beings. That's super intelligence.
Oh, you are already going there.
People are talking about Sam Altman yesterday. Day before yesterday.
I myself am saying we are minuscule in the front of the way they can solve issues.
Yes,
they can
yes.
solve problems.
Yes. And even research will be done by AI. And you're talking about drug discovery and everything. Climate changes. Problems
change,
will be taken.
If the computers take climate change.
Yeah. Now, even now, computers are modeling all that, but the models are not so accurate, right? But now with AI, the models have become so accurate that, all right, when there's something going to happen, you are warned and you leave that place. Okay, just a week back, or a few days back, one place, one village was swept away by glacier kind of thing. Last year glacier burst or whatever. So these things happen, but that was not a warning by the meteorological department or anything. A shepherd saw it and then warned the villagers, and they had to leave. So this kind of things, in fact, practically all problems will be solved. But my question is, will it make us better human beings? That's the thing. We have a lot of issue.
Madam, this is part of the evolution. Human beings were never as good as I see them. I'm not somebody who is pessimistic that way, but AIs, I'm pretty sure, won't have ego issues. They'll just solve their problem. They'll be humble. Human beings' biggest threat is their own egos.
They will not be humble by themselves. They'll not have ego by themselves. We only will make them humble because we are the ones who are going to train them, right? We are the ones who are going to do that. But all said and done, all right, it gives us I don't know how much does it improve our quality of life. That's my question about it. It's not able to empathize with you. It's not able to.
All right,
so
to put in
really,
okay here as well. If I have to put my point of view, of course it will deteriorate us in terms of our efficiency. When vehicles came, automobiles came, our muscles on our hamstrings and all, they got, our leg muscles and all, they got weakened because we don't have to run anymore. We don't have to walk anymore. Likewise, if all this AI would take our mind, our brain's basic functions, then our brain will rot again.
Exactly.
That's what
I don't know
happen.
what's going to happen. And then recently, just a few days back, it seems Elon Musk is building now a robo army and all that. So you have an army of robots who will protect a country.
You won't have soldiers. You won't have patriots like that.
Right. We are already into it. Indian Army has incorporated robotic mules, to carry stuffs in
What do you
high
mean,
altitude.
madam? Robotic mules. Okay.
It's like just like a donkey, a mule.
Uh-huh.
Which has 4 legs, and then it's a robot.
Uh-huh.
So you put your heavy things, or the whatever. The things that you want it to be carried to the high altitude, like snowy areas, and where it's very difficult for human beings to take up. So you just put it on the back, and then just let it go, and it climbs up the mountains, all the high altitude and all that, and takes you. supplies to very difficult regions and so on. So it's already there. Robots are already there. Robots are there even, I mean, robots, of course, it has not just maybe a lot of AI in that, right? So they have in
Robots have a lot of
even
sensors there.
all age homes, there are robots who talk with you and smile at you and that kind of a thing, and you tell nice things to you. But we know that it is fake, right? That's a problem. It's not you. They're telling nice things to you, not because it's really nice. It's just telling, and then you should be able to recognize that it's fake,
Madam,
right?
the robots which are being nice to somebody, they are more real than human beings who pretend to be nice actually.
I don't know what you'll say, but I would always prefer a human being who even pretends to be nice, because it's really sad, because I don't know, the line between reality and virtual reality is really getting blurred. It's very scary, and especially with little children growing up in this age, right? It's
There are certain things that robots can never mimic, and that remains to the judgment of the audience, and we should pursue that. I mean, none of the materials can ever reach there where we can actually, and that's our own pursuit. Anyway, we have hit more than 1 hour mark, and I mean,
Okay.
I hardly put the questions that I was intending to ask you, and because we went almost a linear path starting from there to
Okay.
here now, but I'll still go ahead. It's okay. Let the episode be longer. I don't really care. I'm liking it. Madam, quantum computing, as you mentioned it, I have absolutely no idea. Quantum is a very material concept.
Yeah.
In computer science, how does it fit in there?
Yeah, actually, it uses quantum mechanics. I also haven't done, a deep study into that, but because of this use of this quantum mechanics, we have something like, let's put it this way. Suppose we have the bit, that the digital, we have the bit which can take in value 1 and 0.
By bit, you mean the
By
physical bit?
I mean,
No,
no.
the digital
I'm
bit.
talking about the digital bit of
Okay.
computers. Nowadays, we have this whatever binary. It can take binary values 0 and 1. We're talking about the bit. So now it can take 0. It can take 0 at one time, and it cannot be. It can be 0 at one time, or it can be 1. It can be 0 or 1. That's understood, right? But because of this quantum computing, which uses quantum mechanics, okay, that's a real quantum theory or whatever and all that, yeah, and it's a particular, say, suppose they call it a qubit, right? A bit in a quantum computer is called a qubit.
Okay.
QUIBIT. It is such
QUI.
that QUBIT.
QUBIT,
Okay.
okay.
So this is such that it can be in several states between 0 and 1.
Okay.
All right.
All right.
Now, with this, now you can do so much more. Why? Because I'll just give you a small example.
I almost got the idea, but
You all
yeah.
got the idea, right? You suppose you have locked your home using that combination lock. Have you seen that combination lock? So suppose you have 3
2, 1, whatever.
4 digits in the combination lock. You have your own combination. It could be 9900. You have to put 9900. Then only your lock will open, right? So now a thief comes, okay, and he wants to try out. He wants to open your house. He doesn't know the combination. So now what he has to do? He has to try out. He doesn't know. So he says 0000. He'll start with that 0001.
He'll
You
eventually
understand?
get it
That
actually.
He'll eventually get it. But how long?
It will take time.
A lot of time, actually.
Pretty long time, yeah.
10 into 10 into 10 into 10. 10 to the power 4 possibilities he has to try out. Why? And if you really calculate, it's a lot of time. And so it's a lot of time. If you can, the police will come in before.
Okay.
That's what this is how it is built. All these security keys and all that. We have this number of bits, but to be able to try out all the combinations, it'll take years, even millions of years. So they are not able to break in. That's the idea. Now, we get this, right? So now a thief which uses quantum computing, it's able to try out all the possible combinations at the same time.
Let it sink.
And I'm just trying to put it very simply, but it is that powerful. So if I were a thief trying to break into your house, I would start with 000, then I would start with 00, and then next will be 001, then next will be 0002, and so
Let's
on. I
move on.
go on like this, right?
Ah.
So what am I doing? I'm trying out one combination at one time.
Yeah.
Then it takes how much seconds? Maybe a second or maybe a
2 seconds for
right?
whatever. Put it.
And I go on like this, right?
And now in quantum
Now
computing,
in
what
quantum
happens?
computing, I'm trying to give you a scenario. It'll try out all the combinations at one time.
How? Like
That's what it is. I mean, qubits, these are able to, how will I say, a bit is able to be in several states at the same time. Now, just yesterday, day before yesterday, Google's CEO, Sundar Pichai, he has already announced they have a quantum processor which is 13,000 times faster than the fastest supercomputer.
my God, 13,000 times.
Yes.
It's not even 13,000 times.
And they solve a particular problem called a new algorithm. They implemented that 13,000. I hope it's 13,000. It's 13,000 times faster than the fastest computer that we already have. Now, what's going to happen?
The world is going crazy now.
Yeah, it's going crazy now. So that's the reason why I guess maybe Sam Altman says that super intelligence is coming.
The universe itself had always had infinite potentials. Now the potentials are coming out now. I mean, we human beings are the only species who can unlock those potentials. Because otherwise, like what I'm trying to say is, it's a spiritual concept. Like the universe itself has two infinite potentials, and this is one small part of it that's coming up now.
That is there. So with quantum computing now, drug discovery, everything, elongation of life, because you can find out the genes which are the aging factors, you can edit it, and that
the only thing
things, cure cancer, cure every disease and all that. So all these things are coming in a very, very big way, but how is it really going to improve our quality of life? That's the question.
It can definitely improve the length of our life, as you've said,
Yeah.
because we die only because our material body
Correct.
decays.
Yes. Quantity of life, yes. But how about quality of life? That's the question. That's why it's like very fearful. That's why they're talking about responsible AI, isn't it? All these things, and the government is trying to regulate all this use of AI. But if you have to regulate, you have to have control. Again, if you take control of everything, then we're going to cry out. We're going to say, no, I want privacy. I don't want control. Control will be like you lose your freedom, right? So it's a very difficult, scenario.
The humanity needs to evolve. It's if I have to put it that way, roughly, the humanity needs to evolve its degree of thinking. I mean, they need to have a higher, or more mature level of thinking, higher degree of thinking, higher order of thinking, higher degree of consciousness. Only then, with that thing at our hand, at our disposal, we can still have a very harmonious humanity.
Yeah, exactly.
If these are given to some gadhas,
finish. That's it. That's what's if the super intelligence, somebody takes control of it, and now that's finished, right? That's what it is. So we don't just look at the quantity, but we also look at the quality, and the focus should not be only in this aspect of improving our lives in a quantitative way, but also in a qualitative way. That's what it is, right?
Stephen Hawking was paraplegic, but he had he would consider his life to be of high quality life.
Exactly.
I mean, I would assume so.
It's your perception of yourself. How do you view yourself? Suppose I, as a person, I view that I am created in the image of God. So I think of myself as very, how will I say, special.
Pristine.
As a special, special creation.
Correct.
So when you come to that stage, when you know that, and it makes things very different. So artificial intelligence and all.
That is what I was saying. That is what I was saying.
Quality of life.
When I was saying on the camera that there are certain things that only humans beings have. Robots can never have it. I meant that. The thing that holds you there. I mean, you said you are created in the image of God. That's something that you can hold on.
correct.
with whatever things happening around, with the glaciers falling, with the AI taking
Yeah,
over,
exactly.
you still have something to
Yes.
hold on to.
Robots, you can use it to solve all your problems. You may never have any these external problems, but still you may not be at peace. You may still be crying. You may be sorrowful inside, right? That's the thing.
Madam, okay. Your specialization is something else, right?
Yeah, actually, I'm also into AI now in the sense that federated learning we're doing. Federated learning, I'm doing a little. I'm going into a little portion of federated learning. It's a big thing.
क्या है
That is
federated?
security in federated learning. I'm doing, but
What is
what
it?
is federated learning?
Federated.
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 Federations, federated.
Okay.
So it's like this. It just came out for the need for privacy. Now, suppose we're talking about AI, right? AI takes information from all the world, but then you have like hospitals. You need health data to be able to feed to the AI to train it so that it can cure your diseases, or let's say, right? But if you don't give your data, it's not going to learn anything. It's not going to help you.
Yeah.
Right.
It's as
So
a
now
dummy.
federated learning is like this. Is very interesting. Suppose every hospital has their own servers where they have put in all their patients' data. Okay. This person had the symptoms and in this month, and then it was like this and so on, and then finally it had cancer at this stage and this stage. It's very useful information, right? But they cannot how will I say, expose this data because this is private information, right? And so what federated learning says is that let the learning happen in all the hospitals locally, and then we share what we have learned. I'll just say we'll share what we learned in another form. The parameters, we call it the learned parameters. We share it with the server. The server aggregates the learned parameters from everything and then sends it back to the
What do you mean?
the
Code
hospital.
language or something?
Not code
Pseudo language?
Let us say, what you have learned, like what you have. Now, for example,
No, you
I
have
must
put
say-
the privacy thing here.
yeah, but the data is never shared to the server. But what you have learned, you are sending it. Now, let's just take an example. Let us say that what you have learned is, okay, if I have this symptoms, it is cancer. Suppose you say cancer, right? So now I am saying here like if I have all this if I have all the symptoms, I have cancer, and then I give a big how will I say weight to cancer, saying that for these things the weight is this, and so it's more or less like a neural network that you learn actually, and the neural networks have these weights, okay,
Biases, as you
yeah,
said.
biases. These are like in maths it's called biases, and weights and biases we say these are called the learned parameters, and we share that with the server, which takes all these models from all them, aggregates them, average them, and then send it back to them. Then again they learn from whatever comes,
okay.
and then so you're never sharing your private data, but you're contributing to the
Learning.
Okay.
Oh, you're
And then
evolving.
models.
Okay.
Yeah. So that's what it is, and it's a
Okay.
Google keyword. Many places it's being used.
Interesting.
Yeah, this is called federated learning. It has come about because of the need to,
Secure the
secure
privacy
a
only,
privacy of data.
Is it a new concept?
2016,
That's
17.
pretty new. Not even a
pretty
decade,
new.
yeah.
Yeah, it has come in. So many things are coming up. We are also like kind of trying to keep pace with all these developments, right?
Madam, I would want to see you again with one detailed discussion on one of these topics that we have taken today. When I say detail, you will bring the expertise on the table, and I'll bring my inquisitive questions on the table,
All
and
right.
I'll have my own perspective on it. I'll have a logical perspective. You'll have a technical perspective.
All right, let's see.
Because we have hit more than 1 hour, and in
Yeah.
fact, we have overshot 1 hour 20 minutes as well.
Yeah.
Before we conclude, I want, as according to my plan, you should look at that camera and speak something to my audience about why should you pursue computer science and engineering. Encourage them.
Okay, so computer science and engineering. See, computer science and engineering has actually kind of affected every field, whatever field you have, you say mechanical, civil, or anything like that. So computer science engineering is a very versatile field that way. That's one reason why you can opt for it. Another thing is that it's also a very challenging field because the rate at which the changes are happening, the developments are happening, you should be willing to learn very quickly. You should be willing to adapt to the changes that are around you. I mean, and whatever new things that are coming in the computer science field, you should be willing to learn up, and then you'll be able to do something in this field. Otherwise, if we are just stuck with with something which is the 10 years back or 20 years back, we're going to be stuck. We have to adapt. Yeah. That's
Thank you,
all I
madam.
want to say.
Thank you. It was really
Yeah.
profound discussing all these things with you. I mean, you have opened so many blocks of my mind that I was unaware of. That was the intent, and that was Professor Ningrinla Marchang from our institute from Computer Science Department. Thank you again.
Thank you.